One of the things I was trying to see here was if I could make a bearing hole, something high precision. Because I was doing helix, it did multiple holes to open this up, and it seemed to work really well. I had to push that bearing in. In fact, I think I'm going to struggle to get it back out. But the point is, it actually did do a good bearing hole to the right tolerance. So I am happy about that. Because this machine basically has one last thing left I need to do, which is this handle over here. Once I have this handle on, that's pretty much it. This machine's done. So now that I know this is going to work, that's just one step closer to finishing this thing. These are all the attempts that I've made to make the part. Now, this was the original part. This right here is what was on the machine when the Acme screw was there. Now, this is what these are all modeled after. But when I did the ball screw, it wasn't exactly in the same location, which was the problem. It was a little bit down and to the right. So in comes the problem. So I modeled this part, and then I tried playing with the holes, because it's really hard to gauge where the hole is and how to measure it. And what ended up happening was, it's kind of funny, the ball screw was bent, the first one. So I'd take a measurement, go, I'd do the drawing, I'd print it, put it on, and it would be way off. And, I'd wonder, what the heck's going on? This doesn't make sense. But the thing is, I would use the machine, and, you figure when you're using the machine, the ball screw is going like this. So at the end of it, I take the measurement, I go upstairs, I make the part, I go back downstairs, I put it on after I use the machine again, and now the ball screw's over here. So it was a never-ending battle for a little bit. When I figured it out, I fixed the ball screw. I put a new one on that wasn't bent, and well, as you could tell, it still took me a couple tries to get it right. See, the thing is, it's got to be perfect, because otherwise it puts pressure on the ball screw, which you don't want to do, obviously, because your machine's going to stall if you don't get this just right. So I finally got it just right. In fact, the last one now is 3D printing. That is 100% solid. I'm going to use that in the meantime on the machine until the one that I'm milling is done. It's going to take a little bit to finish it. This is the handle that I bought. I have to put it in the lathe and machine it out to 16 millimeters. This is a special bearing with a 16 millimeter ID. Now the original design was like this, where, let me see if I can turn the light on here. Oh, it's not. And the problem is, this sticks out a little bit too far, because the ball screw doesn't stick out enough. So I have to make it streamlined, a little bit thin, which is why I did away with this nub and I started recessing the bearing into the part. So now the bearing will fit inside. And then I'll just put a cap over it. And then, stupid thing. And then voila. So yeah, I gotta tell you, this one was a tricky one. I'm just about done with this milling machine as far as modifications go. As everybody knows who's been following me, I converted this to CNC, and then I added ball screws, blah blah blah. But slowly but surely I've been trying to upgrade the upgrades to the point where I can't do any more to it. Like, for instance, the motor mounts, I 3D printed this. It's 100% infill, and it's solid. It doesn't flex or anything. But I still went through and made it out of aluminum. So all of the mounts on this machine now will be metal. Just to make sure there's no weak points. This right here has been the biggest pain in the neck. Let me show you what I've made. This is the design that I have come up with. Essentially, this will sit on here. The bearing just barely fits on there. And then you have, your handle. So, unfortunately, trying to design this piece, by measuring it and finagling it, I've done it about 9 times, but finally, I did finish it. So right now, you hear the mill going. That's the part I'm machining out. It'll look something like this when it's done.